Okay. Hello, everyone. Welcome to one more day of, I was going to say the Agent of Code, some habits die hard. Uh, Welcome back to the compiler project. So, today, on Tuesday, we've made a lot of progress. We finally finished a first draft of the parser. We have a first version of the set of types of the AST. It's a bit rough. There's a few things that we might want to change moving forward, but at least it's there. The last thing we did on Tuesday was to make a pretty printer, which is extremely rough, but just like allows us to visualize the result of a pass. And we stopped at that point. What I want to do today is not make more progress on features of the compiler. What I want to do is take a bit of a break and do a bit of cleanup. We've pushed a lot forward and we haven't taken the time to like clean the code we've written so far. So I think this evening what I want to do is clean this AST code and most importantly, I want to write tests. But before that, I want to also just rewrite this pretty printer we wrote last time and make use of an existing pretty printing library to avoid reinventing the wheel. So, yeah, let's get started. The few things I wanted to do, I wanted to also make more instances of lenses. The reason I've named all of my fields with underscores like this is because I'm going to generate lenses for all of those types, which will prove useful, hopefully, in a lot of cases. So that's something I'm going to want to add. And yeah, this is one of the things we're probably gonna at some point change. This is the very long list of all the extension types, which for now are only location. We will most definitely not need that many, so we will definitely clean some of this at some point. Let's do some cleanup. I might zoom out a tiny bit just for convenience for me as I do some cleanups. If it's too small to read on the stream, let me know. I'll just zoom it back. So this is going to be the AST phase. I'm going to keep that a bit separate in the file. Do I want to separate expressions? Probably not. So let's go over all of this. So let me open it here as well. We're going to want to make lenses for module, import, path info. Do I want to make... Yeah, I'm going to make prisms as well for import type. That will be out of the way. Um, I don't think I want to go into a full explanation of like lenses and prisms unless someone is curious about them. But in short, those are template Haskell commands which will run at compile time and generate some of the boilerplate for me. So basically create lenses and other things like this in the module for me, and I just don't have to do it. It's done at compile time. So here, let's do it for all of the types. I want to make prisms for import type. I want to make prisms for declaration. I want to make lenses for type alias info. For enum info. Struct info. I'm still gonna keep the show instance despite having the pretty printing, because show is very useful for debugging purposes, since the default implementation of show, which I'm using here for all of those types, prints something that is basically a valid Haskell expression that I can just paste in GHCI. So for debugging purposes, having the show instance is pretty good. Const info. Function info. And I'll show you in GHCI an example of what those give me in a second when I'm done with writing them. Statement, I will need prisms. If info, I can already pre-write for info while info, and this is also going to be the else info, but that's prism. For info while info, we good. Let info. Expression. Expression, I'm also going to want to have a plated instance, and I think I'm gonna have to write it manually. Make prisms expression. So plated is a class that basically says that there is a traversal, which is a kind of lens from the type to the same type within it. So for self-recursive types. So for expression to all the sub-expressions, basically. Which means plated f will be, and let's do a case of all of those things. Actually, I could have a quick look at the documentation, because if I remember correctly, the very example of plated in the documentation. Oh, oops. The very example of plated in the documentation is for an expression type in an AST. Yep, there we go. Instance plated expression here. I'm surprised that this doesn't call plate recursive. Oops. This doesn't call plate recursively on the function, but just. Huh. Okay. So that's the thing we have to do. I could use the default instance. Hello. How are you? If you want to hear when I started, today is cleanup day. I'm doing a bunch of cleanup of all the things we left in a somewhat unfinished state. Yeah, doing okay. So here I'm defining all of the lens, prism, and other lens-related things for all of the types of the AST. The thing that's missing here is defining plated for our expression. And it's going to be fairly straightforward for most of them. In the case of a path info, there's no expression within a path info, therefore it's going to be pure of the path info, I think. Well, actually, could it just be one of the many case default case? It's just pure E, probably. So that's our default case, and I'm gonna put here. In the case of a field access expression with some expression and an identifier, it's going to be, how do I write this in an elegant way? Do I do it with lift? Do I do it with this operator? I probably want to do it with lift, I guess. So we have the information, which I'm going to call X since the extension field. What we're going to do is basically we're doing this traversal that applies a function to the inner expression and rewraps things back. So here I apply F to the expression, which means the result is a lift A3 of this thing on 3 arguments, pure X, F of E, pure I. There we go. A call expression will be, so I have the extension field, the path info, and the expressions. It's going to be a lift A3 of call expression on pure X because it's unmodified. On the list, it's going to be traverse of F. Is it traverse of F? I think it is, right? Because it's a map, it's a sequence of map. Yeah, I think it's traverse of that list. And yeah, pure P here as a second argument. For an array expression with this and this, it's going to be a lift A2 of the array expression constructor. Pure X, it remains unchanged. And a traverse of F of the array value. I wonder if I can use some regex to fix to... Yeah, I can probably do that. Because all of them take an X, and E1, E2 is a pretty decent default. And all of them are going to be some form of a lift. I can pre-fill most of that function and then clean what's wrong. Lift A2, copy the constructor. I'm going to zoom this out a tiny bit just to see what I'm doing. I'll zoom it back up in a second. And the last thing is I think I can replace all cases of expression P in between parentheses by F of whatever it's going to be, probably some E1, or let's say EZ, so it's going to not compile if it's wrong. Okay, let's fix this. I should have a line on the X. Oh well. So now struct expression has 3 parameters. That's correct. Except they're not. It's a path info and the fields. So lift A3 of a struct expression. That's correct as well. I'm going to attempt to align the arguments here. The path info is going to be given unchanged. Let me know if it's too small. I'll zoom it back if it's too small. So pure X unchanged, pure PI unchanged. And for all that, and for that list, it's a list of tuple identifier expression. It's a traverse of a traverse, I think. I think it's traverse of f of the fields. There we go. For Boolean literals, for all literals, actually, there's actually, I don't have to do anything. There's no expression there. I don't have to handle them manually. There's no need to call the function. For a reference expression, there is no need to do anything. Next, we have the negation expression. Okay, perfect. Just has one expression, and it's just going to be a lift. I don't know if you need to do a... Is there a lift A1, actually? Or is this just lift A? Lift A. And there's no lift A1, but it would be a lift A then. So negation expression applied f of e. And then I'm going to move the cast expression to the top because it is the special case. Here where we have a expression and a type. And it's this here with the type unmodified. And now all of those are the same. E1, oops, 2, but not forgetting the pure X here, which I have forgotten in several places, so let's add it quickly. Okay, it's missing here too. I guess I could align this. Oops. Yeah, okay. That should be enough. Let's try this. So let's zoom this back a bit for readability. And let's try. Plated is not a visible... Oh, I think it's just called plate. There we go. Lift A3 is missing. So let's import control applicative. And I think I just need A3. Here it's E1. Oh, I think this index expression is wrong. What's an index expression? Oh no, it is two expressions, so that's correct. Where are you, index? There you are. Okay, what is wrong now? Oh, yes. This is a lift A3, not A2. And I'm guessing this is a somewhat similar thing. This is a lift A2, yes. Okay. That's a 3. Oh yeah, I think most of those are actually 3 because I had forgotten about the extension type. There we go. And now we should have the lenses and the plated and the everything. Now let's open stack GHCI and let's have a look at what this gives us. Let's do something where we are gonna parse. Let's get an actual AST to try things on. Let's parse a module that contains a function foo with no argument that contains a let x equal 3 and return x. Okay, what's our AST? Our AST is this thing here. Actually, I'm gonna even go one step further. On left, undefined. There we go. Okay, so now we've passed an AST. We have a module that contains a function and declaration named foo with a bunch of things. Now what we can do is, what do I want to do? As an example, I can define an increase literal function that is doing over. So that would be module declarations. That's the lens that has been declared. Function declaration, that's the prism that has been declared. For the function declaration, it would be the second field, because the first one is the location that we don't care about. The second is the function info. In the function info, I want the function body. And for in the function body, that's a list. It's going to be a traverse. And I want, in this case, let's do for the sake of an example, let statement. And that contains underscore 2 is going to be the let info, let x, which is the expression of the let, which is a literal exp. And the second argument will be the value. And over this lens, I will do +1. Okay, I need to import control.lens. And probably need to import the AST as well. Okay. It's not literal. It is literal int, I think, that I want. Okay. Still wrong. Because declaration. Okay. Mode declarations, traverse. Okay. So here, literal int exp is wrong. What's the name of the constructor of expression? It's int literal exp. There we go. Okay, so this absolutely horrible thing that I've defined using the lenses and prisms we have declared is I'm saying over within the a module's declarations for each of the declarations, for the function declarations, for the function info, the function body, for all of the statements, all the let statements, the let info, the let expressions, the int literal expressions within it, and the actual value, do a plus one. Which means, given our AST here, if I do an increase, and you will notice that we have somewhere let name equals x, let expression is an int literal expression value 3. If I do an increase literal of this AST, that's because that's interesting. That's yes, okay, of course. So that's because my AST is wrong. My on left is wrong. I should do this type of AST. There we go. And now this should work. So now we had the literal 3 here. We do have the literal 4 here. So this increase AST thing worked. So that's the lenses and the prisms we have declared that allow us to do that kind of like, this is a bad example, but the gist of it is this: doing access through getting a lens to the specific thing we want within a more complicated expression. So that's done. Oh, we should try the plated as well. Let's do I have parse expression? I do have parse expression. Let's do an expression that is a plus b. It would, since I'm doing a traverse, it would not do anything. It would only apply the thing on the ones that match, and it would apply it on all that match. And in this case, there's only one thing that matched this very, very specific thing, but it would have increased, this thing would have increased the int literal value of any let statement in which the literal value is the first argument. So it's a very rough and very inelegant use of lenses, but just to show the things we have defined, what they can be used for. And if I do something like this, which is a lexical error in I'm guessing we've never tried passing the expression with Alexa, and I'm guessing that there's something wrong with. If I do a 0 here, that works. Fascinating. So we have a bug in the Alexa. Oh, great. I'm guessing it's because we never considered the possibility that an identifier could be at the end of the input stream, because it cannot be the case when passing a module. That's a bug we can fix. Okay, so if we do this, we have an expression. What would I want to do with this? I guess I could try a rewrite to children. I could try children to start with. Children of E will be no instance for show. Oh, yes. That's not what I meant to do. From right is the right. What am I? What's the function I'm looking for? I'm looking for a function that extracts. There isn't one. I thought there was one that would force. That's fine. Okay, so now we have this expression, and if I do, so it's the subtraction expression that has the things on the left, and on the right has just the int literal expression that has a 0. And if I do children of E, I get a list, and I get that on the first element is the addition expression that was on the left, and the second element is the int literal expression that was on the right. Okay, so yeah, that's plated for us. So we've defined those lenses for future use. Okay, so the only thing left to do in terms of cleanup that I wanted to do for this module is I've looked into pretty printers and pretty printing libraries, and there is Pretty Printer. The title is not visible here with the way the screen is set up, but the Pretty Printer library is, there we go, seems to be a recommended one. And the upside is it's going to simplify a lot of the code of the Pretty Printer. I just make a bunch of functions that for each type in the AST return a document, and then the combination of documents is handled mostly by the library. So let's do that. I'm going to add another section in this thing for the Pretty Printer. I need to add a dependency on Pretty Printer that I'm just going to put in the library here. Is that the name? No space. That's the name, no space. Which means this function is now obsolete. That's fine. And instead, we're going to have a bunch of instance pretty module where. Okay. Which means I can copy things from here where they are. Let me just have a quick look at how this works again. So this is going to be basically, I'm going to call pretty everywhere. That's fine. And I just need to use one of the separation functions, which is one of those or those. Okay. So in the case, so pretty of a module is going to be I apply the pretty function recursively on all of the imports. And oops, that's not the right syntax. There we go, and the declarations. And I separate them vertically. I think that's correct. Okay. Next, what do we have? I think there's one thing I need to check is how binary function list functions. I want to check how to make, there is already a pretty instance for most types. I don't think there's one for text interest. Ah, there is one. Okay. Which I think is fine for identifiers because it's just about printing them the way they are. Nest and inline is the ones I want. For indentation, I'm tempted to make use of hang for some of the I think I don't need to bother for now. List is going to be useful. And there's a few more. Punctuate could be useful for comma separation. There's more. There was another one I'm looking for. There's those for brackets and braces. The upside of the library is it reduces the amount of code that I have in my file that deals with string concatenation and string building. Basically, I make use of the pretty printing library in which I say this is what I want the thing to look like. Do the rendering, and it deals with the actual string for the actual string, like dealing with the actual text. So I do a separation of concern. My concern is to say what the layout should be, and the library becomes responsible for all the string manipulation. So it cleans this a tiny bit. And yes, pretty printing in this case is mostly for debug. But also the upside is the library supports doing different kinds of rendering for like very compact things for some cases, or like full HTML rendering for some others. So if we wanted to have like a full debug option at some point that debugs the AST, print something, we could make use of that. The library is more versatile than what I had hard coded last time. So I yeah, a tiny bit. I separate the concerns. I write what my layout should be, and I let the library do the thing. Which again also reduces the amount of string manipulation within my code, which I think is always good. So here for an import, I guess I can. Can I do the smart thing here? Can I do? No, it's not gonna be easy. Okay, so let's undo that. I'm just gonna bring back here on the left the same file so I can see the types of the things I'm dealing with. Import doesn't have a type parameter. Okay. So here I can probably use the other functions that are defined in the library. This is separated horizontally with spaces, which I think is what hsep is for. Yep, that's what it is. It's the use keyword. This is the punctuate function. Wait, putting separators at the end. There's an enclose with separator. There we go. That's not exactly correct, is it? I think this could be just be a regular intercalate. Yeah, I think this is going to be a regular intercalate. This into prettifying the path. So I get the let me think. I see. What I was doing was, so I should probably do a this and a concat like I had before of a series of lists. There we go. And this list here is, it really depends what your goal is. Since you are saying that you don't know much about programming, the question is, what is your goal? What are you trying to achieve? What is the thing you want to get out of learning something? I would always recommend Haskell, of course, because I love it, and also because I feel like a lot of languages take inspirations from it. And as a result, if you understand Haskell, there's a lot of things that other languages do that you can be like, oh, that's where they got it. Or, oh, their thing is a slightly more restricted in a simplified version of what Haskell does. So Haskell will give you a very useful perspective on other languages. If what you want to do is get some code out the door quickly slash get a job in the industry, Haskell might not be your best first choice. It is not the easiest language to get started with, and it's not the most in demand. So it really, really depends on what you want to achieve. If you want to get programming with if you want to get a video game out, don't start with Haskell. If you want to understand a lot of the beautiful ideas behind the theoretical computation, yeah, Haskell, perfect. Yeah, I think you're not wrong. Lisp has a lot of very interesting ideas in terms of like the language being its own AST more or less. Like there's a lot of interesting things about Lisp that make it very interesting on paper, and in practice, your mileage may vary. I don't have any professional experience with Lisp. I do have professional experience with Haskell, but not with Lisp. So everything I say with Lisp needs to be taken with the appropriate grain of salt. But the question of like with which language should someone start is a debate that is as old as programming languages, and my answer is really it depends on what you want to achieve. I know some people who really recommend, okay, if you want to become a software engineer, start with C. It is not as close to the metal as it is, but it is still fairly low level. It will give you an intuition for like, okay, how does memory allocation work? How do all the low level things of a programming language work? And from this, you can extend to higher constructs. Some people will say, no, start with Haskell or OCaml, start with an extremely high level thing to understand the logic, and then you can see how it gets translated into bare metal stuff. Some people will say start with Python because the syntax is easy. It's an easier way to get in. Some people will say start with JavaScript because it's one you can easily test anywhere and is also a very practical one that you might have use for immediately. There is no good answer. There are a few bad ones, but ooh, that's fun. I think my only thing is like don't start with Java. Just don't. But otherwise, yeah, it really depends on what you're trying to achieve. So here the upside is we can rewrite this as just lists. We don't have to do all the concatenation ourselves. Um, So for now, I'm basically just rewriting the thing we wrote last time, but this time to make use of the existing pretty printing library. Again, today is cleanup. Then what do we have? We have. Oh, do I want to do. Would it make more sense to define. No, it probably doesn't make sense to define the pretty instance on the import type, which is a type that doesn't make sense outside of import. Yeah, maybe I can keep it that way. Okay. Next, those are straightforward. But also, yeah, I was thinking about this thing about programming languages. I said Haskell might not be the best to start with. I think there's a bit of bias here. Haskell is very different from other languages. So if you have some background with any imperative language, the Haskell learning curve can be a bit difficult. But I don't know anyone who has started with Haskell without any knowledge of other programming languages. And I'm fairly convinced that it's not actually harder than any other programming language. It's just that, like, if you have all of the habits of other languages, then having to unlearn and relearn is what is difficult. I don't know if it's actually more difficult than other languages. Like, I'm fairly convinced learning the basics of Haskell as the first language is a lot easier than C++, which is a complete nightmare. I mean, I like C++, but you know what I mean in terms of complexity for a beginner. This thing is a helper function that. Yeah, we might want to make that helper function. It might come in handy. That's going to be for a list of. What's going to be in the list? I think it depends, which means I need to make it generic. So for any type that happens to be pretty fireable, and I have a list of those types, and I return a doc, which is the type from the prettyfire library. And in case where it's empty, I return empty. And otherwise, there is a function here. It is angles. It is angles of intercalate with comma of map pretty params. Ooh, that's interesting. Yeah, I started with. It depends. I started with basic on my old TI 89, and then my school made us started with both OCaml and Delphi 7, which was an interesting combination. Delphi being Pascal with objects before moving us to C and C++. Yeah, I know, right? But that was back in 2000. 2005. So I'm sorry for the PTSD flashback of suddenly Delphi being mentioned. Ooh, pen and paper is a bit more rough. I could try. Yeah, that's probably correct. It's gonna save me some time. Yeah, I had managed to had managed to convince my parents by not exactly lying, but perhaps slightly exaggerating that the TI-89 was really the one that my math teacher was recommending. So I managed to get that one, and I was learning how to program BASIC directly on the calculator itself. So I had an editor that had like 4 lines and like 20 characters per line, and I was trying to write stuff in BASIC on it when I was bored in class. It was fun. I got a PDF version of one of the C books and the C, or the C++ one, I don't remember, that I printed page by page until I had like something yay thick in a binder. So yeah, somewhat similar. Kids these days don't realize how good they have it. Um, this is one of the cases where it's going to be pretty useful here. I might want to use the punctuation function because it's where one of the things where like it's gonna break it's like it's going to break properly on new lines depending on the rendering of the like if the thing fits on one line it's gonna render it on one line, if it doesn't fit on one line it's gonna break it down properly. So here this is an example where I probably want to use I started with gen 2 which was fun. What was the function I'm looking for? There was another one that was enclose sub. There we go. Left, right separator. Left is gonna be this. Right is gonna be this. Separator is gonna be this. And we're just gonna be doing this on map pretty of the enum values. So here we don't have to do any of the string manipulation anymore. We let the library do all of that for us. Ooh, I back in high school it was what was it? Was it Windows 95 or 98? It was an old. I mean, it was high school computers that were extremely outdated, and the teachers there were not exactly the most computer savvy. So all students had the same had you were using the same account, which was account student with password student, and all teachers were using the same account, which was teacher. I will give you one guess at what the password of the teacher account was. But then my computer science school actually had some pretty decent stuff. I don't remember if it was NetBSD or OpenBSD that was on most of the machines. I know that even though the school had so many machines running that particular OS, it was one of the biggest sparks of either NetBSD or OpenBSD in Europe. Just my school, but I don't remember which one it was. I think NetBSD. I still use FreeBSD here for my small server. So this is going to be. Yeah. We are old. It's fine. We've seen the evolution of we've seen how this industry and has evolved. Solaris, I haven't touched a Solaris machine in probably 15 years at this point. There was one at school. We had to make all of our stuff work on NetBSD, on Linux, on Solaris, on an HPUX, I think it was, which is a system I've never even heard of since. Which means we had to deal with like NC compatibility for C, which was a nightmare. Yeah, it's. I was mentioning it last time. I used to do a lot of tricky stuff with installations. The more time has passed, the less I am interested in doing the system administration, and the more I use high-level distros that do a lot of the thing for me. I just like Mint or Manjaro, and I just don't want to worry too much about the actual details because I. This is no longer the part that interests me. I've done it a few times. I still maintain like again my FreeBSD server because that's fun. FreeBSD is fun to tinker with, but I don't do as much like sysadmin as I used to. It's not the part that I find interesting. Okay. Oof. What am I doing? Okay. So yeah, again, I'm cleaning the pretty fire because that way that's out of the way, and the next step is writing tests. There's a few spaces that remain. Oh, thank you. I've said it in previous streams. I've deliberately not engaged with any of the Twitch features like rewards for subscribing and everything, because I don't want to provide incentives to subscribe, because that's not the reason I'm doing this. But I nonetheless really appreciate it. So thank you very much. And yeah, sorry, you've subscribed on the cleanup stream when I'm just cleaning the code. I hope it's still interesting enough nonetheless. Don't know what this one was. We'll see. Oops. Okay, so again, there we can simplify a bunch of things. Here I can do the same thing again. Except functions are different, I think. I'm not gonna complain. It's nice to do a bit more of a chill stream for once, of like not trying to push to just get the parse out of the way and just slowly clean the code and make things a bit nicer. Here, however, what do I want to do? I think I have to do this manually here. Yep. This is going to be an HSEP. There we go. Of rectify the name. Okay. Yeah, all the stuff we had to do last time about dealing with spaces in the strings, because we had to like deal with like, do we have add a space because the thing is missing or not? We don't have to do that anymore. The library does that for us, which makes a lot of things simpler. We don't have to close the function arguments. Those are done. That remains correct, I think. That's a full map, that's the same. Um, can I simplify this? I could make it 0.3, but I don't think it would be as readable as this. So probably not. But I can remove the spaces. They're gonna be added for me just fine. And now we can do the same thing here and close. Um, Pure is... Oh, this is opening a can of worms. Pure is a function in the applicative class, and it is just put this value into the applicative, into the context. For instance, maybe happens to be an applicative. So if I want to create, a function and I want to create it just for or nothing, I can use pure for instead of the just constructor. It's like pure for as a maybe int, gives me just for. Lists are also applicative. Pure for is going to be as a list is going to be the list that only contains for. Either of string is also an applicative. So pure for is going to be for an either string int is going to be right for. So it is a generic function in applicative that creates an applicative that holds that one value, basically. And here, where do I use pure? I use pure in... Yes, I use it here. I'm using the do block thing, which is syntactic sugar for any monad. And I use it for the list one. So this is basically kind of a list comprehension in practice. And I use it to just like, this needs to return a value of type list, and I have only one value to return. So I use pure to just yeah, exactly. Return is the same thing. Pure was introduced afterwards. That is part of the some of the things that are probably gonna be changed at some point. Between functor and monad, applicative was introduced at some point and basically needs the same thing that return already was. So pure and return do the same thing. But there is a push towards let's remove return from the language and let's always use pure, since I don't think there is a single case where it makes sense for the two of them to be different. I think there's even a warning in some case. No, it's an HLint thing to have a warning if you use written instead of pure. It is the there is there's two benefits, I would say, to using pure over return. First, it's a bit more generic. Some types are applicatives but are not monads. So if you're using pure in a very generic function context, that function might generalize to any applicative functor and not just to any monad. So there's that there's the added genericity, although that's a very small bonus that's rarely going to matter. But that being said, there are some extensions of the language to like use the do syntax for just applicative, in which case you just don't have a choice. So using pure over return is more generic, allows for some optimizations and some language extensions. The other thing would be, since there are proposals to remove return from the language altogether, using pure over return makes the code slightly more forward compatible if those changes happen, like were to happen. So overall, using pure is I think the the better option. I think there's a small added benefit, but that's very niche one, which is return can be confusing for people who arrive at Haskell from more imperative languages, because it does not like interrupt the function's execution. So some people will arrive at Haskell and do a return for and then do more stuff, and like, why is the stuff after the return still executed? Because that's not the return that interrupts the control flow that some people might be used to. So using pure also removes this slight ambiguity. So usually pure is the right call. And again, I think HLint nowadays by default has a lint warning for like, you should use pure, not return. Here I was doing, yes, the statements will be enclosed between brackets, but not necessarily separated by... So actually this is not an enclosed sep, this is a... Let's punctuate that's there, it is braces. And it is just braces of map pretty fun body. There we go. I don't know how to indicate. I would need to read the documentation. There is probably a way to indicate that I want some things to not be put in a single line if I can. Like here at the end of at the beginning of the braces, this would be a good place for. This would be a good place to actually put a new line. Let's see. I also want to indent this hard line. Yeah, it's probably what I want here. So I probably want to do an indent by 2. Something like this is probably correct. Or I think nest 2 might be the right one. We will see. I'm doing something like, again, the chill stream. I'm using a library I've never used before. So we'll see. We'll see how that goes. This would be, what is this? This is a statement. Something is weird here. Why do I have? Oh no, I remember. Yes, it's because I wanted to put the braces. That's no longer required. Those are all HSEP. There we go. How do you find libraries? That's a good question. For a lot of them, a simple Google will work, and sometimes you will find 5 different ones, and you'll find a Reddit post that link tells you which one is actually the good one. But otherwise, yes, that is the correct answer. Google is often, well, it depends. It can be the right one to find libraries, yes, uh, but Google is a bit more useful for like I am looking for something. Let me put this here. Just this is much more like, okay, I know the name of the function that will work for this, or I know the type of the function that will work for this. Which libraries have it? What's the name? But that is a good way to find libraries. Although sometimes, like again, if I were to look for an image manipulation library here, like maybe trying to like look for an image function might be the right approach. But I would start with just like a regular Google search of just like, let's look at what Hackage has to offer. But here, however, yes, Google can be extremely good for like what example do I want? I have an either string int, and I have a default int, and I want an int out of this, and it tells me immediately from right is the function that I want for this. Google is absolutely fantastic. Yeah, I don't find the category browsing of Hackage to be that useful. I think partly because it's a bit freeform, and as a result, a lot of libraries just like don't use it in a very consistent way. I mean, it's not bad. It's just I don't think it's the most useful way to find libraries. Okay, so that's the same thing. Here I can simplify this to being a fold map pretty, which is nice. Here, I don't even need to do that. There we go. And here, I can probably just use this. And here, I can do the same. Okay. What do we have next? If info. So here the prefix is no longer something that makes sense. This is going to be still mostly horizontal separation. Let's have a look at what we have to deal with. Pretty print basically renders into an internal type, a document type, and can render in different. If I look at the rendering, it can render as text, as HTML, like directly print to a terminal. Like it has a bunch of different options, and I do believe indeed it renders to text. And it has like a few render IO and everything. So this is probably what we're gonna be using. I assume they have some kind of builder underneath to avoid unnecessary allocations, but I haven't looked at the implementation. So here we can simplify this quite a lot. Yeah, probably. That feels. I don't know the library very well because, again, I looked it up today to prepare for the stream. But it feels like, yes, probably you can just like use some of the layout options to write your own. Yeah, there's a lot of things that people would like to change. I know some of the steering committee have proposed a bunch of like breaking changes to try to like change things in the language, making changes to the data list, removing return in favor of pure. Like there are suggestions to make some breaking changes to the language, making string less of a prominent type is I think is on some people's radar. Because if you're not familiar, yes, the string type, the default string type named string in Haskell is a single linked list. And that has some performance implications. Namely, it's bad. So, yes, text is usually text byte string tend to be the ones that are used most of the time. I just think here this is gonna be this without the space, prettify the if expression, and then we are gonna have the same thing we've had before for the function info, which was uh, this. Except I probably want to do this. There we go. And I'm gonna copy that. So nest to the vertically separated of map pretty of the body. How do I do this? I don't need to actually have the braces there because they are part of the thing that are already finished. So here, this is just going to be the else, and then pretty this. And if it's an else block, I guess I already have a function. I have a helper this. I'm going to make another. Ah, thank you. I'll fix that in a second. I'm going to make a function for this, which is going to be given some list of things that are pretty fireable. Make them into a document. I'm going to copy the thing I keep copy pasting. This one. So that's braces of a hard line of nest 2 of vertically separated of map pretty. There we go. So now I can use that here. This is going to be pretty block. Same thing here. If body. Oh, yes, you said I had a typo for MMT somewhere. Yes, here. Thank you. So here this is correct, I think. And then for the else block, I think this needs to be else plus pretty block of B. Okay. Here, likewise, this is going to get a bit simpler. I can remove all the spaces that are no longer required. And then that's just a block, so I can do the same thing. And is it for body? Yes, it is. Likewise, this is going to be a bit simpler. There we go. Okay, so there again, we can simplify a lot. Here, I'm gonna, it was nice as 0.3, but I think it's gonna be better if I don't and make it explicit. There we go. Oh, I left a few spaces. There we go. Let's clean that. Okay. Oh, the only downside I see is in a lot of places I should Yeah, I should do that. Because otherwise it's gonna insert a bunch of spaces before semicolons, which is not gonna be very elegant. Yeah, especially since this is always going to be... Hmm, let me think. I think it's fine. Worst case, we have a few spaces in before semicolons, and it's not the end of the world. I think this one is the only one that remains. Oh, no, this one too. That being said, I don't like leaving things slightly inelegant. Let's fix this. So here, I'm gonna need to introduce a few helpers. I don't need to. I can just wrap this in parentheses and then add the semicolon at the end. Okay. Actually, here this is probably a good use of... but I want to list here. Still, I think this could be a good use of... So that's the opening character, that's the closing character, the separator is a comma. There we go. And the result of this, then we give the semicolon. There we go. Okay. Okay. Okay, so I think now we've fixed our semicolon problems. What do we have left? We have expression. Okay, this one is gonna be a bit more tricky. Oh, I'm just reminded that I have not. I should probably import pretty printer. Lowercase. Okay. So what do we have here? A path expression is just a print of the path info. That makes sense. For a lot of the others, this is just... I'm tempted to try to do it in one go. So if I have this with this, Hmm. Okay, it's gonna not be correct, but it's still gonna be a lot of the way done. So this is gonna be replaced by braces. Oh, not braces. What am I saying? It's gonna be replaced by parents of pretty of this. Oop. I can probably actually do it better. With parents dollar space replaced with parents. And now to fix the typo. There you go. And that way I can also control how I want things to be spaced, which is nice. Mhm. Actually, this is one of those. How is it called again? Enclose sep thing. With parents as open and close, comma as the separator, and the thing that's gonna be in between is gonna be just. Oops, a bit too eager there. Is gonna be a map pretty of the arguments. There we go. No, it's gonna be an H sep of map pretty. There we go. It's one of those cases where I think I'm gonna do the thing I did last time, where I'm going to do that just to have a tiny bit more visibility at this extremely high zoom level. Okay. For the array expression I'm going to use, I had looked, there is a list function in this module. Where is it? It's called list. That's definitely not going to conflict with anything, but it does render things properly with brackets and everything. So I want to use list of map pretty well. Yes, I don't need to do the h type or anything. Map pretty values. There we go. There again, relying on the library to do the things for me and not doing any of the string manipulation myself if I can. An index expression is going to be yep, followed by brackets of now. This is not gonna be a proper block thing, so I can't reuse my previous one. But this is nonetheless somewhat similar to what we had before, where now Here I can probably... do I want to say... Okay, this is where the limits of me not knowing the library well enough. I would probably want to say that, like, okay, if we have space, then this should be rendered vertically. If we don't, render it horizontally, and but clearly indicate that this is a good breaking point for that. And I'm not sure how to do that, so I'm not gonna bother for now. So this is... Okay, yeah, I don't need to do that. I can just do the usual... This is the enclose separator thing between braces using comma as the separation, and the list is this list comprehension. Yep, there we go. Aha. There is a way to simplify this. Because there is a function to create a document from the show instance. There we go. Since here that's good enough. Okay, and now we just have to fix all of those remaining string issues. Now, remove this. Surround the operator with this. And then this is all... I'm gonna align this first. There we go. And now I can delete most of the stuff in there. Oh, actually, no, this needs to be between parentheses as well. There we go. Okay. This was a bit verbose, but that should be basically it at this point, because expression was the last one we had left. Now we can try this and see that it doesn't look as good as the handcrafted one, which is okay. I am not too concerned about it looking like since it's mostly going to be used for debugging and testing purposes. I don't care too much about it not looking too great. I mostly prefer the fact that I no longer have a bunch of hard coded, like a very large hard coded function, and now I have a bunch of pretty instances, and I can fix this a lot. Like I don't have to maintain complicated functionality. For this one, yeah, I could probably just like I could probably make a helper for this. I'm only missing the path info. Fmap, okay, and then this feels like a bit ugly, but that's fine. Okay, and that should be all of it now. This is never gonna compile on the first try, but I don't expect it to. What is missing? Here, I probably want to move the helper functions at the end just for consistency. Okay. What am I missing? I think that should be all of it. Now, let's try to compile this. It's never gonna be... it's never gonna compile on the first try, but that's okay. Yes, I no longer have this. There we go. Yes, there again, I use an intercalate, which gives me a list, of the documents, and I need to say how they should be rendered, which is this H separator thing. What next? Probably... Ah, yes, here I have the concat thing, which is not required if I use this. So here, that means it can also be... Okay, so here it can be simplified to just a document, so I can use it directly like this. MMT here. Doesn't have to be a list, it's just a document, it's this one. It's just that. Okay. What's the type of intercalate? I never remember. Oh, it is... It is not what I thought it was. Is it interspersed that I want then? It is. Okay. Args not in scope. That's a good point. This is a function info, so there is a fun args probably. There we go. Yes, here this is just a an enclosed thing, so the map is enough. It's not too bad, honestly. It depends on what you're doing. Those are pretty like it's just also I know exactly what those are, so I'm just going quickly. But like here at this very specific line and column, couldn't match this type with this type. Not the worst. Not the worst error message. Oops, that's what I meant to do. I meant to go. Okay, it's this line. I'm assuming that I've used a map where yes, here I've used a map and expected list of identifier actual non-empty. In the second argument of fmap. Oh, because intersperse expect this to be a list, which it is not, because this is a non-empty list, which is fine. I can make it a list since anyway I'm gonna combine it back afterwards. Okay. Aha. Here, I probably want to group this way. Okay. Ah, yes, here it's a list, so I don't need to do. There we go. The main kind of errors I'm dealing with here are either I have a list of things and I need to use hsep, vsep to like indicate how they are supposed to be combined into a document, or I have the enclosed thing that expects a list. So if I use the wrong one, then I get a list where I'm not expecting one, or not a list where I'm expecting one, and that's most of my errors so far. As you can see, still here. This is expecting not a list and I give it a list, so I should say that this list is resolved by being separated horizontally by just spaces. Hardline is not. Okay. So I should put that at the beginning. So something like this. Okay. Last time I used the. There we go. So I should probably make a pretty print function as well. That gives me some text based on this. And let me just quickly look at the documentation for this because I don't remember. The default layout one is okay. Layout pretty with default layout options, which gives me this simple doc stream here. And if I go back to here, render lazy, render strict. Render strict is perfectly fine. So I want a render strict of layout pretty. It's probably gonna miss some imports. Yes, render strict is need to be imported from pretty printer. Render text. Okay. So now we can try the things we were trying last time. We had a test file, if I remember correctly. Yeah, we had this test file. Let's try. Huh. I'm surprised I don't have it in my history here. So there was a stack run PC, and I give it the test file. Okay, so this is how it renders, which is absolutely horribly ugly. I mean, the indentation is correct, at least. I think I just need to put a hard line before the closing brace. I think that's the thing that's missing. Yeah, I think that's the thing that's missing. It needs a hard line before the closing brace. And it's probably going to put a space before the closing brace. And that's not the end of the world. Yeah, there's a few things where it does things weird, and I'm okay with that. It doesn't. Oh, this, however, is bad. So in function info, I have a issue. Oh, because I still have an mconcat here, which is incorrect. Okay. And I guess I can change my block function. Is there a surround? There is. But enclose is what I want. Okay. So I want to enclose hardline, I think. Okay. Any second now. Okay. Ah, I don't have the proper indentation for the function block, so I need to fix that. I don't know why, actually. Wrong braces? No, I think it's fine. I think this is just closed by this one, and this one is closed by this one. But for some reason, the if is not... Like, the indentation starts one line too late, it seems. I wonder if it's because I do the enclose. Maybe I should do an indent instead of a nest. The thing is, it's good enough for our test purposes anyway. It's just that at the moment it's an ugly print, not a pretty print. So let's try to see if we can make it at least somewhat. That looks better, I think. We have one space too many here. That's because of the possible return type. But otherwise, yep, that looks decent otherwise. We have a few too many spaces here because of the way I can fix that probably, I think, because I think it's just a matter of choosing. I've been using H set. There we go. Is there a way to do the same thing without H cat? There we go. So for those, I probably want an H cat. And there we go. Okay, let's try that. After main. You're right. This after we think after main is completely wrong. What is that? What is that? So here, did we fix? We fixed some of the issues. The terminating thing here still has a space that's not really required, but that's not the end of the world. We do have, however, indeed, this weird thing in the function, which I think is the function generic types. Yeah, I think it's the fun parameters here. Oh, because here I'm using the wrong function, I think. Huh. I would kind of want to. Yeah, the reason why it puts some additional spaces is that this, even if it's empty, ends up taking room for one thing and therefore ends up being concatenated as being one space. Could I solve this easily? I don't know. I think it's not the end of the world. I'm okay with that. Okay, there we go. So we have the space too many because there's no generic type parameters and the space too many because there's no return type. But otherwise now I think we fixed most of the issues. Yay, we've spent 2 hours remaking the same code we already had, but slightly worse. Let me just try something. If instead this function has type parameters and a return type. Yep. Oh god, yeah, that's definitely ugly, but it is. It is correct if slightly ugly. Oh, except for the function return. I'm gonna fix that quickly. Where is that? Here, this should take a space. And for the parameters, which is my helper function at the end. Ah, yeah, I see. I probably want to hcat them and intersperse with this. Okay. Or actually, I could instead rewrite this as there we go. Does negation still work? Negation here is a very interesting corner case. I use the same constructor for expressions to represent negation, whether it's Boolean negation or integer negation. So for the pretty print, I'm always printing the Boolean one because I don't have enough information in my AST to necessarily print the correct one. But if in this test file, so here, if I have let x equals minus 42, this is probably going to be printed as, yes, this not instead, this negation, which for the case of our pretty printer is acceptable again because having an AST from which we can reconstruct the exact source code was something we deemed out of scope for our purpose. So this is just a way of visualizing the AST in a way that we can write tests with and nothing much more, which is why I'm okay with like things being slightly not perfect in terms of rendering. That's because, again, mostly you're going to be used for tests. Speaking of tests, I think with this being out of the way, let's write some tests. So I have some ugly tests I'm going to remove because I have some end-to-end tests that are supposed to test something where they're not correct. I have this idea, and I'm going to test it better now, where basically, since in theory, outside of string literals, weight space doesn't matter, any amount of weight space can be changed, and the file should pass the exact same outside of string literals, which is very important. And I had made some like template to have this property being tested, but this is not good at all. I'm gonna remove this test. Instead, we should be adding some integration test, I guess. What do we want to test? There's two things. I think we want to make a series of golden tests where we pass a given test and we output the pretty print of what we have passed, and this should always be correct. There's like, if it changes, it means either we've broken the code, like there's been a regression in the code, or we've made a change that we should check is correct. So a series of golden tests I think would be good. And we probably want to also make some quick check tests that test like that for some arbitrarily generated AST. If we pretty print and pass it back, we should always get the same. We should get the same AST back. So let's do that. I'm just gonna copy some of the things here. I'm using a library that auto collects all the tests. So it runs at compile time to generate a few things for me, which means I don't have to worry about listing all of my tests myself. It's going to do it for me automatically, which is pretty convenient. So what do I want? I'm going to want a list. I'm going to want a bunch of golden tests, which are going to be those ones. What's the syntax for golden tests again? Where do I have some golden tests? In my unit test, I think? No, I don't think those are. I think those are just regular unit tests. Where do I have some of my... Oh, not in this project. I think it's in this one that I do have some gold tests. Let's see. Yes, there we go. Let's see what that looks like. Test tasty golden. Um, I have this go function. It's a golden versus string, which is not what I want. Okay, so let's go see tasty golden. Golden versus file. Test name, path to the golden file, path to the output file. Okay, golden versus string is probably better indeed. So this is probably what I want. Test name, path to a file that stores the canonical output that I'm supposed to get. Action that returns a byte string and gives me a test out of this. Okay, so this is indeed the same thing that I have here. I'm gonna use a thing I've made already, which is this locate thing. Which is a tiny bit of template Haskell to run at compile time, which allows me to list the files in a directory that match a given extension. Which means here I can generate at compile time a batch of tests based on the list of files that match this suffix in this folder. And for each of them, I can then return a test case where what I'm going to do is for each of those golden files, what I want to do is I want to do a golden versus string thing. The name of the test will be the base name of the file that is correct. And then I need an action that returns an IO byte string. So reading the file, okay. Then I'm gonna parse module that's the file name and the source. That gives me the result of parsing the thing, which is going to be an either of an error or the resulting AST. Which means on this, I can do some either in the case where we got an error that's never supposed to happen. Unless unless I want to also have tests that test that we do get, but I would be testing error messages. I don't think that's what I want. So I think for now, error, just like crash the test if it fails to pass. That's never supposed to happen. It's going to report an error. And in the case where it does, then we can do a pretty on the module. Is there a way to render into byte string? No, this returns a string and this returns text. Is there no way to get a byte string? No, which means we're gonna have to do the render text and then so pretty print. AST text is gonna be this. And then that means we need to return a byte string out of this, which we can obtain from text. Text has some conversion functions to byte string in the encoding, I think. Where is that again? Data text encoding, there we go. Encode UTF-8, perfect. So encode UTF-8 of our AST text, which means I can probably just return that. Okay, so for each file in this folder listed at compilation time, we create a golden test where we compare against a file on the disk, which will be generated the first time and then always used as reference and should never change, which is the result of reading that file, parsing it, and pretty printing the result. Okay, so that's gonna be our golden test, just like for a bunch of simple cases, check that. Oh, wait, no. I need to specify the file name as well. Okay. Where is this file going to be? Because this file here is the input file. I guess. There we go. So test name golden file. And for each test, what we do is we read the input file, which I'm going to rename test input file for readability. Okay. Oh, actually, and I also need from not this. From this, I'm gonna need a few more of those. Text builder, no. Golden, yes. Test, yes. Okay. Oh, is it a lazy? What does tasty need? Aha, it's a lazy byte string. I see that I had that problem on this thing here. I need to remember to remove this before I stream. That's fine. That's not a compromising notification. So here I'm gonna need to change this to be a. I'm gonna copy this again. It's already copied. So I'm gonna need to do a encode of from strict. There we go. Okay, so that should give me a bunch of golden tests immediately. I can already try that. And then we'll do the quick check tests, which are going to require writing some arbitrary instances, which is going to be a bit more work. So let's try to do this to start with. I'm also just going to quickly go here and just delete that because that is not required anymore. And here I need to create a folder parsing that has I can just add a file in this and it will create a test case for me. So let's do a very basic test. Which will contain a use foo bar star, a const answer, which is going to be 42, obviously. And enum, actually, I can just get my test file here because it was already. Sure thing. Have a good night. Thank you for tuning in. I'm just gonna reuse the test file I was using for my test. I'm just gonna clean it a tiny bit to make it a bit less messy because I was testing stuff about spacing and the lack of it mattering. So here's some a very basic example. Okay. So let's try running this test. Let's see what happens. It's obviously not going to compile at first. Oh, I forgot to bring snacks. What a mistake. Okay. Couldn't find module golden. That means in my dependencies. Yeah, tasty golden. Ah, I made the mistake of recompiling in Emacs, which means I'm recompiling without test mode, which means I'm recompiling a bunch of things, but that's fine. Okay, so this compiles. Stack test, let's go. Read file is going to be in text IO. I think. Okay, we're getting more. I can actually probably do just a stack test here. There we go. Yes, this is now named as the test input file. pretty print not in scope. That is correct. I need to import the whole project. Wait, did I not? Oh wait, no, it's called. Okay. Parse module, and that's gonna be, yes, test input file. Okay. Now this should hopefully compile and then run the tests. Let's see. Okay, so here the test run with our parsing thing. It tested against the golden file, which is the name of the test plus golden, realized it didn't exist and created it. And now there is a file in integration parsing here. There is the, wait, it did not, where does, huh, golden file didn't exist created. Why does it, oh, because I know. I know. It's because I have made a mistake. And I think the file has been created here. Basic golden, it is here. Yes, okay. So let me remove it. And let's fix this. The golden file will be because tech base name basically only took the actual thing, so basic, remove the path. So what I want is probably to look at system file path. And basically I want to remove the extension. Replace extension, that's exactly what I want. Or I can use this operator, because of course there's an operator for this. So this golden file is the test input file, but with golden. Now, let's try this again. Perfect. Golden file didn't exist created, and now the golden file should be here. Yeah, there we go. So now we have this file, which is a bit ugly because our pretty printer is not very pretty again. But what it did is it tested, it read the file from the input, pretty printed from the test file here, and did a parse of the entire thing, and then did a pretty print of the result. And now, basically, since this file exists, every time I make any change, I can rerun everything and check that the pretty printer hasn't changed and that none of the changes we've made have broken the way this was parsed and pretty printed. So if we have at any point any like weird thing where like parsing something is wrong, I can just add a new file in this, and it will create the golden file, and then I have a golden file that I can always compare against. So that's one good thing. Now the other thing I wanted to do, there's this test property thing, and I have one in my encode. No, I don't. Where did I have one? Oh, I had one in my white space thing that I have here remove. Test property. There we go. That's what I want. So here what I want to do is I want to do a property, which is a property of a module passed. And it is a property. Okay. And what I want to do is, given some module, I want to check that if I parse the module after doing a pretty print of the module, I get the same module back, basically. Given any arbitrary module, pretty printed, pass it back, I should get the same value. Now, for this to work, I'm going to need to explain to quick check how to generate arbitrary properties. So we are gonna need to do that, which gonna mean orphan instances, which is a bit inelegant, but that's fine. Here I have a file that's empty. There we go. So I just need to tell it how to make an arbitrary module passed. So this is going to take a while. Let's open the AST to compare. And making an arbitrary module is making an arbitrary number of imports and an arbitrary number of declarations. Which means I'm going to need an instance of arbitrary for an import. Okay. This is going to take a while. I'm going to need an instance of arbitrary for identifier, which I think identifier is for now just a type alias, not a new type. So that's kind of ugly. If it is, this might be the good time to fix this. Let's see, quick check. Oh, there it is. Because I want a identifier to always be a letter. I think there is a way to say such that. There we go. So for an identifier, the way to generate an arbitrary identifier is going to be. Can I say? Can I ask for a list? List of. Yeah, perfect. List of. Non-empty. Perfect. So I want a list of 1 of arbitrary characters such that is letter And it gives me a list of characters, which is a string, and I can map a back on this to transform a list of characters into text. There we go. So that's the identifier done. So that's for the import path. We are done. For the import type instance, arbitrary import type. Arbitrary is going to be, there is a choose, I think. Choose, but that's one of. One of is what I want. Arbitrary is going to be one of, and I'm going to make a. Doesn't indent, which means something is wrong somewhere in this file. We will see what at some point. So here, an import type is either going to be qualified arbitrary or specific arbitrary or pure exhaustive. Then arbitrary declaration is going to be one of, with a constructor for each. I'm gonna try to compile this afterwards just to see what's wrong. Type alias declaration. I probably want to make, since I don't care about the locations at all for the test purposes, is there... Oh, excuse me. I can just, I guess, use an initial location. Or actually just like have debug location. And a debug location is a location named debug 000. I guess I don't have to do that. I can do this. Then we have enum, which is going to be the same, basically. It's going to be the same structure for all of them. Okay, so that's done. Let's see already if anything in here is wrong before we push any further. It's not. That's what was wrong. There we go. Okay. Oh, yes, of course. Excuse me. Those need to be. Okay, so so far, so good. This compiles. Well, this compile. Uh, Up to this, then it's missing the next instances of arbitrary, which is fine. Which means we can start doing everything else. I am tempted to do something ugly. I'm gonna do that. I'm gonna copy that here. Um, Okay, and I'm gonna just generate a template, which is arbitrary instance for that type. Okay, it's not probably not gonna be correct for most of them, but at least it gives us a template to get started. And save some typing time. So what is type alias info? I mean, I wasn't too far. Lift a3, type alias info, arbitrary, arbitrary, arbitrary. Enum info is the same. Lift a2, enum info, arbitrary, arbitrary. Struct info is the same. Const info likewise. Function info is a bit more interesting, but I think it's still the same. Is there such a thing as lift a5? Oops. Nope, there isn't. Or at least not there. I guess for function info, I'm gonna do it manually. 1, 2, 3, 4, 5. There we go. Function archetype is not one of those. It is a one of by value arbitrary or by reference arbitrary. A statement is also going to be a one of. So that's, I'm just going to copy that. This is all the debug location because I don't care about it. And the rest of this is a bunch of arbitrary. Except for return and continue, I think. Yep. Those do not have. Sorry, break and continue. So those are just pure continue statement and break statement. Which means I'm gonna group then that way for clarity. There we go. Okay, we move on to if info, which is again a lift a3. Just copy here. Else info is instead a one-off. Oh, however, I might want to use, since it's self-recursive, there's a thing in the generation monad for arbitrary where like I can say to reduce the size when going recursive to avoid generating infinitely big things. Sized. Scale is probably good enough. Okay, I can do a scale leave too or something. Yeah, I think it's something like that. I don't remember the exact details, but it's something along those lines. So anything that's self-recursive should be reduced. So in the case of an else, we have two options. And I'm just gonna always do a scale div2 of one off. Is it where it is supposed to be? I think so. And it's either an else if of some arbitrary if, or it's an else block of some arbitrary list of statements. A 4 is just a lift a3. And while is probably just a lift a2. Yep. Next, we have a let, which is back to being an a3. And finally, expression, which is going to be the big one. Since it's always going to be scale div2 of one of. Let's copy this list. Zoom in a bit, just for readability for a second. Okay. In all of them, the debug location can be replaced here. We're going to replace this thing here. There we go. And all of those is just going to be arbitrary. Path info is also going to be arbitrary. Identifier arbitrary. Arbitrary as well. Arbitrary for a boolean is fine. However, for an integer, we're gonna want to say that we need a positive integer because the literals are never negative. That's not how they're passed. There is no... interesting. I thought there was modifiers, perhaps? Positive. There we go. So if I make this... Okay. So here I want to make sure that I do get a positive int. So here this is going to need to be a get positive of arbitrary. All of those are just arbitrary. Which one? Yeah, I think that's all. Okay. Some things are going to be missing. This is not enough yet. Yeah. Okay. Lift A3 then in scope. Let's fix that. Aha. Oh, because this is not an if info, it's a while info. I forgot to fix this. Okay. Anything else that's wrong? No. Path info doesn't have an arbitrary instance, so that's going to be missing. No instance for type expression, no instance for path info. That's the last one, I think. What's a path info? It's this thing. And this one is also gonna be a lift A2 of path info. Arbitrary. What's missing? No instance for arbitrary non-empty identifier. Huh. That's fun. I didn't realize there wasn't a So we need to generate something. So I do need to do a list of 1 into a non-empty. Which I think is the from list. Yep. So let's import data list and non-empty qualified as an E. This on this line. This one specifically, this is going to need to be. I am going to apply, so my arbitrary. It's going to be an arbitrary whatever the item of the list is, list of 1 to guarantee that it's not empty. And in the result, I'm going to fmap a from list to get a non-empty list, which is a different type. Couldn't match. Huh. Wait, what's the type of a path info? Oh, non-empty is the first argument. Okay, import is unused. We like it. Let's see. Test prop expected the name of the string for the test. What did I do in this one? Ah, yes, of course. Bi-directional. That's not true. Round trip. Not in scope property. Ah, yes, I'm using equals, which is not correct. I need to use the one from quick check, which is this one. I need to import arbitrary, which I'm gonna put separately just because it is a weird name for a file. There we go. No instance for, yeah, of course, I don't have any equality on modules. Do I want to have a notion of equality on all of my AST, despite the fact that it doesn't make sense at all outside of tests? Or do I want to do something else? And I guess I could. I could do the equality on the pretty printed version. That's a bit ugly, but that should be fine. So yeah, I have this AST as an argument here. I can make a first version of the pretty print. And the second version is pretty print of parsing the first pretty print. So I pretty printed random AST, I parsed re-pretty print, and then I compare the pretty prints rather than comparing the ASTs, just because I don't want to add a notion of equality to my AST where it makes no sense for the rest of the project. And my property is print1 equals print2. Let's see if we manage to find counter examples. Okay. Aha, we found counterexamples. And this is probably because of string literals, I assume. Parse error. We've managed to generate a parse error. Ah. So this monstrosity is broken. The question is it because hmm. Huh. Well, we have a thing to debug, I guess. Oh, this is weird. Type here. Oh, I think I know what the problem is. I think I know what the problem is. It's the same problem we had in the pretty printer with functions. If I go back to my AST code, when I printed functions, I had, if I go back to function info, I had the problem here when I was not using pretty params but just pretty, and as a result, I was printing the list of type parameters, if any. I was printing them wrong, and I think I have the exact problem, but for type aliases. So if I go for params, yep. So with a bit of luck, that was the bug. And it was a pretty printing bug, not a parsing bug. Let's see. I want to believe. I want to believe. That's big. I might want to put a cap on the size of the generated ASTs because this is monstrous. Actually, it just should be. Yeah, just a full CPU core and half of my memory. At least the upside is Since I'm not using OBS on this machine, but on another machine with a capture card, if my if it starts swapping and it crashes, the stream should remain up. I should probably just kill it before it dies. Let's see what the quick check manual has to say about generating slightly smaller. Yeah, I'm gonna kill it because my computer is absolutely dying. Oh, this time it found the thing. Okay. Aha. This one generated a lexical error. Fascinating. So we're finding a bunch of errors thanks to this test, which is good, but also a bit frustrating. I was hoping it would work. So this doesn't work. Okay, let's try to replicate this. Uh, so the example here that fails is just a const declaration with a string literal and a semicolon and some garbage. Yep. So this passes, but this doesn't. Oh, is it because it's probably because we don't handle this syntax. Oops. We don't handle this syntax for characters in string literals. That's what it is. So we encounter this and was like, oh, this is a string literal escape that we don't recognize. Lexical error. So that's the problem. That can be fixed with changing the instance of arbitrary so that for string literal expression, I can do something. What can I do? Actually, I'm just gonna. So if I have arbitrary, I can do a list of arbitrary to get a bunch of characters. And I can say arbitrary such that is alpha is digit. That's not great because we're not generating. interesting string literals for this. Let's say lower or something. So that should fix that one. Oh, I'm also gonna change divide by 20 the scale here for expressions, because otherwise my laptop is gonna die. Oh, and I should probably do the same thing here. It's a list of with a capital O. Okay. Reducing the scale so drastically will, with a bit of luck, be enough. And if it works, I'll probably try to reduce it a tiny bit. This gives me... Yes, so I need a back to make this string a list. Okay. Can we find another error? We found another error. Oh, because we generated an empty list of identifiers. That's interesting. If we go back to our AST, yeah, I guess the import path here can be is a list and therefore can be empty, which it should not be. So I'm gonna change this to be a non-empty, like I have for some in some other places, to remove that possibility altogether. I'm just gonna break a few things. Because I now need to do a toList here. And there's probably going to be one or two more places where changing the type like this is going to make it unhappy. Perhaps even in the parser. Yep. So we need to go back to... this is in the imports. Yes, this is no longer a list. This is... If I look at data list non-empty, which is already open, I need to open it again. How do I create one element? Is there... There's probably a singleton. Yeah. Okay, so we are no longer creating a list, we're creating a non-empty list. And when I prepend the import, this needs to be changed to no longer be... Yep, there we go. Okay, not in scope, that's fine, because it's already imported here. I can just add it. Okay. The instance for arbitrary is going to be wrong as well. We're going to need to fix that. Yep. No instance for an arbitrary. So where did we use a from list? Or I think at the end here. Yeah, there we go. So for imports, the first element is now a non-empty list and needs to be this. I guess I could make an orphan instance of just like, as long as the thing within the list has an arbitrary instance. God. Huh. Expecting identifier. Oh. Aha. Yes, okay. That is a problem that is going to be more difficult to fix. And I don't think I'm going to fix this evening. Here, our arbitrary instance is able to generate things that would not be valid in the code. In this case here, our reference is a reference to an expression, which is not something that we allow in the grammar of the language. It would need to be very specifically it would need to be a path specifically. Okay, my brain is fried, so I think it means it's time to stop. But nonetheless, we are getting close to a point where we have useful information out of this test. We fixed a few issues in the AST thanks to the quick check tests. There's a few more things to fix. The arbitrary instances are a bit too arbitrary. Because they might generate ASTs that do not make sense, that we are happy to represent, but that the grammar would not accept. So that's something we need to fix. I guess I can quickly fix that one because it should not be too hard to fix. I think famous last word, but it would be a path expression always before. If I look at the grammar for a reference expression is always, yes, before a path expression. So that means here, if I use that for a negation expression, this cannot be any arbitrary expression. It needs to be I'm gonna put it separately because it has a shape that's different from the others. But that's basically the gist of it. Okay, still found a counterexample. Oops. That was the wrong button. Okay. What is left? Okay, so we still have some. What do we have here? Make sure, yeah. So we have a use thing followed by a function with type parameters that returns a type which is a random character, while one. Oh, yeah, I suppose. I don't know, actually, I'm not sure. But this seems to be an error with the way. Yes, here in a call expression dot something, a field expression, is it called? Field expression? No, that is. A field access expression. We're always expecting an identifier, not a random expression, which means our pretty printer, by putting it parentheses here, confused the parser. So this is the fault of the pretty printer. Okay. Oops, that's not what I meant to do. Argle. Well, I'm typing the wrong keyboard shortcuts. It is really time for me to stop soon because I am getting tired. So I wanted to fix here. It's the pretty printer in the case of an expression, in the case of a field access expression. Where are you? Field access expression. There you are. This needs to not be in parentheses. Okay. I don't think the scale thing I've done was enough because it's still taking a third of my RAM. But at least it's not finding anything obvious, which is nice. Okay, I'm gonna, in the meantime, have a look at the quick check size of test data. There we go. Should always use the size control mechanism. Ah, okay, so I have to handle the size myself. Oh, I'm swapping and I cannot go back. Okay. I've managed to kill it, I think. Nope, I have not. Okay. So what I need to change is on everything that is recursive, I need to use the scale thing. If I understand this correctly. Let me zoom this so it's readable on stream. The size, the list generator interpreted as an upper bound on the length of generated lists. So for statements, I don't need to bother because for every statement, like if, while, all of those, since there are lists of statements, even in the worst case, since I do the div2 thing recursively, I should never like I will reduce the thing without having to check manually. So that's fine. So go back to arbitrary div. Let's switch to like a div2 still. I think I want to have large test cases. Statements, yes, we probably want to div2 anyway. Expressions, we want to div2, like we want to do it everywhere. But I think the main place where it's important to deal with it is here. Because this is not going to generate a list. This is going to be generating the tree. And here for the tree, it needs to be sized. So what's the thing? I'm going to take their example. Okay, I'm going to take their example basically. So if we reach 0, I always return a literal, I suppose. I guess I can do a one-off like this still, and only keep the ones that do not have expressions, which is gonna be very few of them. A path expression is fine. I guess path expression and literals is fine. Because, yeah, it's just a bunch of identifiers. So if we're too deep, the test case is too big, do one of those. And otherwise, if I'm still at the size n. Recursively going is going to be going with the value divided by 2. And we do the same one-off that we had before. Except for all of the expressions we are going to use this is not going to compile because I'm using it on some of the wrong things, such as here. This should be arbitrary. This should be arbitrary. Here as well. And here as well. And a few others as well. I think here this is incorrect. Yes, this is incorrect as well. Correct. However, this is where... no, I don't think I want to do that. Hmm. Let me think. The problem is like here, if I use arbitrary when it's a list, then I'm not calling with the div2. Um, so I probably want actually to use the scale. Yeah, I think I'm going to change that to be back to arbitrary everywhere because that's easier. But I can probably do a scale div2. Would that work? Let's try that. This might not be working. That's still monstrous. Hmm. Let's try being more aggressive. I wonder if this doesn't actually work the way I expect. Let me read the documentation for scale. That should be fine. Even with div 10, it's not decreasing. I'm surprised. Is there any other place where there's recursion that I have missed? Not that I know. Well, at least in all those runs where I'm trying to debug the scaling thing, in all of them, at least the it doesn't find any counter indication, which is nice. Any counter example? Aha! I spoke too soon. What did you find? Okay, that's a monstrous thing. What's the issue? Oh god. That's not what I want. I want you to expand. Incredible. Okay. No guaranteed that I will find the same thing. Why does he not expand? Fascinating. Oh, if I run it in terminal, I have a... Okay, so I don't know what's wrong here because I can't see the error message. Can I copy this? Oh, quick check replay. There we go. Hmm. Interesting. So Knight's complaining about this not being a valid... Fascinating. Okay. I am therefore not sure what's wrong. This one, I can't seem to get the error message out, which is absurd. Can I just copy and paste it? Nope. No, I cannot. Incredible. So I don't know what's wrong here. And I'm surprised that this use quick check replay thing doesn't work. It's literally the one that has been given to me. I'm not sure why this doesn't work. Well, I think that's a sign that I should stop for the evening. Because I am tired, and we've made some progress. Aha, we got another one. Oh, and this one is easier. Okay, so this one is the lexical error. Let's see. We got use something as something that's fine. Const. Hmm. A lexical error on this. That's interesting. I mean, I am tired. I'm trying to write this test case. There we go. If I look at this file, Okay, so what's wrong with it? Why doesn't it pass? Hmm. I don't know. That should pass. The fact that it doesn't is interesting. Something to investigate for next time, I think. Yeah. I can feel that my brain is no longer working. At least we got. What did we do today? Rewrote. We did the entire rewrite of the pretty printer to use a third-party library rather than doing string manipulation by hand. We did a bit of a cleanup of the AST module, and we started adding tests, and we found several little issues both in the pretty printer and in the AST itself while debugging the tests. That's progress. I wish I had finished the tests, but it's getting too late. I'm stopping here. We're gonna finish the tests on Tuesday. And after that, either we start some of the compilation phases or I'll do some of the bytecode stuff depending on how I feel. Okay, yeah, I'm stopping here. My brain is fried. But thank you for tuning in. It was fun. We've made some progress and we have now many bugs to debug. And yeah, I hope you have a good weekend and I'll see you all on Tuesday.